This video will work through problem 5.1 of Gapenski's Healthcare Finance 6th edition. Okay, in problem 5.1, the book gives us two graphs that look pretty close to what I've drawn here. And the first question, part A, is assuming the graphs are drawn to scale, which provider has the greater fixed costs, the greater variable cost rate, and the greater per unit revenue? Okay, so these are fairly straightforward. If we look at A, where do we see the fixed cost documented on this graph? And it is documented here, represented here, as this horizontal line. So fixed costs are represented as a horizontal line because as volume increases, so as we increase volume, the cost, which is what the y-axis represents, does not increase. So if we have that, it'll be there. So if we do 0 visits, our fixed cost is whatever it is here. And if we do 1 visit, it stays the same. If we do 1,000 visits, it stays the same. If we do 10,000 visits, it stays the same. So the higher this line is, the higher the fixed costs are. So when we compare the horizontal line in graph A to the horizontal line in graph B, what we see is that B has the higher horizontal line, right, relative to the origin. So it has higher fixed costs. The next question asks, which has the greater variable cost rate? This is a little more subtle to look at, but variable cost is drawn onto the CVP graph starting at the y-intercept, which is represented by the fixed cost line, and then goes up. Now, the book and my drawing don't make the difference in angle here all that huge, but if you look here, you can see that A's variable cost line, or total cost line, really, we should say, total cost, this is fixed cost, total cost. The total cost line is a little steeper than B's total cost line. Now, the total cost line is based on variable cost, and it in fact represents variable cost, which is this portion of the graph, plus the fixed cost. So the whole thing here is total cost, right? But the bottom portion is the fixed cost contribution to total cost. The top half is the variable cost contribution. So we're basically taking the variable cost line and plopping it down on top of the fixed cost. If we were going to draw a variable cost by itself, it would look something like this, right? It would start at 0 when we did 0, and then it increases incrementally with each additional unit of volume that we do. So the steeper this line is, the steeper the slope, the higher our per unit variable cost is. So this would be a variable cost line. So we're basically taking this line and dropping it on top of the fixed cost up here. And why do we do that? Again, because total cost is made up of fixed cost plus variable cost. Okay. And then the third question is, which has the greater per unit revenue? Well, the revenue line, or total revenue line, is this line here. And it starts at the origin because we're operating under a fee-for-service model in this case. We're assuming we're operating under a fee-for-service model. And so when the healthcare organization does 0 volume, 0 visits, 0 tests, whatever, it is not able to charge anything to any patients because it hasn't done anything. But we're assuming it's got some average revenue per visit or revenue per test or whatever that we multiply times the volume to get total revenue. So total revenue is really the price that we charge times the number of visits or volume or whatever it is, whatever volume is going to represent for you. So the steeper the total revenue line, the higher the price, right? The more revenue per unit of work is being generated. So looking between these two, you want to look at kind of the angle again, right? And I tried to draw it so clear that for B, the total revenue line is significantly steeper than on A's. Now, what we're really comparing when we say it's steeper, we're really saying, what's the slope, right? So the slope here for each of these lines is different, right? The variable cost slopes are relatively lower than the total revenue slopes. And so eventually the total revenue exceeds the total cost given enough time. All right. Part B says, which provider has the greater contribution margin? So contribution margin is price minus variable cost. So contribution margin is the price minus variable cost. So if I make, if I charge $100 per visit, so that's my price, and I have supply costs of $20 per visit, my contribution margin per visit is 80. So it's really a comparison between the slope of the revenue line, which is equal to the price, right? So this is, the price is equal to the slope of the revenue line. So we can see here what we would say is, well, the slope of A's revenue line is shallower or lower, smaller than the slope of B's because B goes up at a faster rate. So this would be the difference between, say, 100. Let's say B is 100, right? And if this is shallower, then A's must be, say, like 75. Okay, so if we assume B is, say, 100 because it's steeper than A, and then we look roughly at the total cost line, and the total cost line, and in particular, this is the slope of the variable cost contribution to the total cost, is steeper than it is over here in part B. So A both has a smaller slope for its price or total revenue line, has a smaller slope for its total revenue line, and a larger slope for its total cost line. So both P is smaller and VC is larger on A than either are on B. So my assumption would be that B has a larger contribution margin. But this is all visual, so you have to kind of eyeball it. That kind of question works better when you have numbers. All right. Which provider needs higher volume to break even? The break-even point is the point where total revenue equals total cost. So that's where the total revenue line crosses the total cost line. So we have total revenue here, total cost here. So if we draw a line down from each, what you can see is to get to the break-even volume, I'm going to abbreviate that BE vol, right? And this is the break-even point, break-even point, break-even volume. So we have to go farther along the x-axis, the volume axis, on A than we do on B. And again, we're eyeballing this with a visual representation. It always works better with real numbers to do this kind of comparison, but you can kind of get the point. If you measure that versus that, right? I think I've done a decent enough job representing that. So the key here is to know that where the break-even point is, so that you can calculate or demonstrate the break-even volume, right? So the break-even point is where total revenue crosses total cost, and that will tell us what our break-even volume is. All right, and the last one. How would these graphs change if the providers were operating in a discounted fee-for-service environment or a capitated environment. So in a discounted fee-for-service environment, depending on whether the discount applied to the entire volume that the providers were providing, or if it only applied to a particular part. So let's assume that the discount is applied to the entire volume that the provider is doing. So it doesn't have a mix of higher and lower paying patients. Everybody pays the same. So what happens, probably it'd be better to just draw a new line. So if this is my total revenue line, undiscounted, if I take a discount, so that's like at price P, right? If I take a discount, which means that price P is going to be something smaller than it was, right? So if P is now was 100, and let's say the price discounted is now, say, 75, what would that look like if I drew it on here? Well, I'm going to use the 75 as my slope instead of the 100. Because 75 is smaller than 100, I'm going to draw a flatter total revenue discounted line with a new slope of PD, right, which is 75. So that's what would happen under discounting, and it would happen presumably to both of them. So it would depend on if we brought back A and B, what would happen? It would depend. Is it 10% off for both of them? Is A getting 10% off and B getting 25% off? It's hard to, so without more details, can't really answer the question perfectly. But what is true is if you're operating under a discount, if you suddenly have a discount applied to your entire volume, then what would happen is your slope would be reduced and you would see a rotation of the revenue line down, still originating at the origin at 0, but it would rotate down and become flatter. Now, what happens under capitation? Well, so what's the assumption under capitation? Well, capitation, revenues become fixed because they're no longer based on volume. They're based on the number of patients that you are enrolling. So like fixed cost, which is straight out like this, because it doesn't change as you add additional units of volume, as you move along here, the fixed cost just stays fixed. So if we're renting, if our fixed cost is the rent on our building and it's $1,000 a month, the landlord expects to be paid the rent, whether you're doing 0 visits or 1,000 visits. The landlord doesn't care. The landlord just wants his or her $1,000. Well, in a similar vein, if your revenue is based on a per member per month rate times the number of members, as volume changes, there's no effect here because volume isn't in this number. This is going to be something like, $50 per member per month times, say, 1,000 members would be 50,000. So if these members come into your clinic 100 times or 1,000 times, your total revenue doesn't change because it's not part of this equation anymore. So your total revenue, hopefully, would be above your fixed costs, and it would be constant. It would be a constant number, like, say, 50,000, right? Because that's what you get whether you do 0 visits or thousands of visits. It doesn't matter.